Hello students, welcome in your classical mechanics class. In this lecture we are going to start your unit 2, that is we have already completed half of the syllabus of your classical mechanics course. So this lecture we will discuss about the central forces. The definition of central force is: if a force acting on a particle is a function of the distance between the particle and the center of force, and the force acts along the line joining the particle to the center of force, then the force is said to be central in nature. That means by definition, force F is equal to F, it is a function of position R into r cap is unit vector along the line joining the center of force to the particle. Let us consider we have a heavy mass located at the origin O of the coordinate system and a small mass small m is moving under the influence of this force. The force between the two particles is gravitational force between the two masses. So the force is gravitational force. So this force is a function of r only. R is the distance, that means OP, unit vector OP, and it acts along the line joining the particle to the center of force. So F r cap is unit vector along O to P and F acts along P to O, or you can say O to P, and in the direction of force is opposite to r cap. So this is the definition of central force. So mathematically we can represent vector F equal to Fr r cap. Since the gravitational force, the force between the two object having some mass small m and capital M, or the electrostatic force between the two stationary charges, are central in nature. Now we will discuss about the properties of the central forces. First property is central forces are conservative in nature. Central forces are conservative in nature. What are conservative forces? You can go to previous lecture on conservative forces. Second point, since the central forces are conservative in nature, so they can be expressed as the negative gradient of some scalar function or the potential energy. Gradient of corresponding potential कर लो, that is better. Corresponding potential energy. So this is all about this is F is equal to negative curl U upon curl R. So this is force is negative gradient of some scalar function. So r cap is the unit vector along the direction of force. So this is why we write, you can go through the central forces. These points are already discussed in that lecture. Now the third point is when a body moves under the action of central force under the action of central force, its angular momentum is conserved. Now we will look at this point, how the angular momentum is conserved. Since we are considering that the object M is moving under the action of force F, the force between these two objects is gravitational force in nature. So by the definition of gravitational force, we have F is equal to Gmm upon r square into r cap. So this is the definition of gravitational force. You had already learned in your senior secondary classes how we write F equal to minus Gmm upon r square into r cap. Now since this force acts on the mass small m, so the path of this object is like this. So the torque acting on the mass small m due to center of force tau is r cross F. Now this r is the distance OP. So r cross, we know about F is minus Gm m upon r square into r cap. So from here this is a constant term minus Gm upon r square. It is not a vector quantity, it is a scalar quantity. Now vector r cross r cap. Now vector r and r cross. This is vector r and this is r cap. This is r cap along this direction in the increasing direction of r. So they are parallel. So r cap cross r, vector r cross r cap is 0. That means tau equal to 0. Now by the definition of torque, tau is rate of change of angular momentum dl upon dt. Since tau equal to 0, so dl upon dt is equal to 0. From here vector L is constant. So it is not only constant, it is a vector quantity. Angular momentum is a vector quantity, so we will write it a constant vector. So that's why we write when a body moves under the action of central force, its angular momentum is conserved. Its angular momentum is conserved, that is constant vector. Vector L is a constant vector. This is the important property of the central force. Now next point is, fourth point is, when a body moves under the action of central force, its motion is confined to plane. Now we will discuss about this point, how the motion of the object is confined to a plane. We have a frame of reference, y-axis, x-axis, this is z-axis. Since we are interested motion is confined to a plane, so this is a xy plane and z-axis is perpendicular to the board containing this xy plane. Now here is a heavy mass located at the origin M, this at point O is the origin, and a small mass moves under the action of this gravitational force in this plane. So here is small mass, let it be at point P. So this is the vector R, OP. Now this is the linear momentum m into v. V is the velocity vector, v linear velocity vector. Okay. Now by the definition of angular momentum, you know in your senior secondary classes L is equal to R cross mv. If you have any doubt about the angular momentum, concept of angular momentum, you can write me. I will try to explain about the angular momentum and linear momentum. So vector L is R cross mv. Now we know L, as in our previous discussion, when a body moves under the action of central force, its angular momentum is conserved. Yes, that means vector L is a constant vector, as we discussed. So vector L is a constant vector. So we know vector L is R cross mv, is a constant vector. If you had already gone through the vector product of two vectors, then you can see this is vector A cross vector B. Now vector A cross vector B. So R cross mv, this is R, this is mv. So I will keep my right hand like this and rotate my fingers from R to mv, and then the direction of cross product is along this direction. This is the z axis perpendicular to the plane, this board. So it is perpendicular to the xy plane. That means vector L is perpendicular to the xy plane. So as we discussed in third point, angular momentum is a constant vector. So this is a constant vector only if R and mv lies in the xy plane. That means the motion is confined to a plane. This is all about the fourth point. When a body moves under the action of central force, its motion is confined to a plane. So that means vector L is perpendicular to both the position vector vector R and the linear momentum vector mv, or you can say let it be vector P. This is all about the central forces. Now again I am repeating the definition of this central force. A force acting on a body is said to be central if its magnitude is a function of the distance of the particle from the center of force and act along the line joining the particle to the center of force. That means vector F is Fr into r cap. R cap is unit vector along the line joining the two particles, and F is the force. Since force is a function of r only here, so if we talk about the gravitational force between the two masses, small n and capital M as in this case, or the electrostatic force between the two stationary charges, then these are the two examples of central forces. So this is all about the central force. Thank you for watching.